Hi everyone, my name is the vet. You say that like when your dog gets sick, you take it to the vet. And I'm not pedantic about pronunciation, so if you want to talk to me afterwards, you're just totally welcome. I'm going to make a confession up front that I like Liveview, and I want you to like Liveview, but at the same time, I don't want you to dislike Liveview. And so I'm not going to spend the entire talk time trying to convince you that Liveview is amazing and it's perfect in every scenario, and you should choose it for every technology project or every software project. Because if you did that, you might end up choosing Liveview in a scenario where Liveview's strengths are not being given an opportunity to shine. And then you might dislike Liveview, which, like I said, I want even less. So kind of the structure of where we're going today. We're going to talk at a high level about what is Liveview. As we try to introduce Liveview, we'll come across Elixir. So then we'll first talk about what is Elixir, when is Elixir a good fit, and then a bit of a deeper dive into what is Liveview, a little bit of how it works, and then when is Liveview a good fit. So what is Liveview? Liveview is a tool for building interactive web applications, and we'll continue that in a minute. If you're using Liveview, you're using Elixir on the back end. So Liveview on the front end, Elixir on the back end. So you're kind of stuck with that. Like if you're using Liveview as the original thing that sparked many other things, then you are using Elixir on the back end. That said, the programming model of Liveview, having some benefits in some scenarios, and especially a productivity benefit, has sparked many other frameworks to build similar things. So if you Googled, I want something like Liveview in XYZ backend web development framework, there probably will be something. I know there is for all the popular ones I know of. And also, you can use Phoenix and Elixir without Liveview. So if we go through some of the benefits of Phoenix and Elixir, and you realize, man, the scenario in which Phoenix and Elixir shine really closely aligns with the problems I'm solving, you could choose that and still not choose Liveview. You could have Phoenix and Elixir on the back end, and you can have REST APIs or GraphQL APIs or WebSockets to front-end JavaScript clients or to mobile clients. All right, so I'm going to start with reasons not to use Elixir, just because I might come across a little bit strongly about how great Elixir is, and I want you to trust me when I do. Elixir has not, or Phoenix, definitely not Liveview, has not gotten to the place of popularity that it would make it into this sentence where IBM is. I'm not saying anybody's gotten fired for choosing Elixir or Liveview, but it definitely is not known by non-technical business leaders as the safe, responsible business choice. And so that is a reality. If you ever make the technical choice for Elixir or Liveview or any other obscure or less well-known technology, and then something goes wrong with the project and people start blaming you, it would be a serious ding on your reputation. Worldly wisdom teaches that it is better for a reputation to fail conventionally than to succeed unconventionally. Now, this is a quote from John Maynard Keynes I really like. When I am among other engineers, I sometimes get a really odd look. It happened this past Saturday. Ran into an acquaintance at my daughter's swim meet. He's in software, I'm in software. We know some of the same people in Atlanta. And he asked me, hey, you still at SalesLoft? I said, no, I was at SalesLoft 6.5 years, but I switched to Cars.com earlier this year. And he asked me, oh, what kind of tech stack are you running? I said, yeah, we're doing all Elixir on the back end. And the expression on his face looked like I offered him some clearly expired food, and I brought it too close to his face. I think he recoiled a little bit. And honestly, I just chuckled. I thought it was really fun. It didn't hamper the rest of the conversation. But where it has been not funny is when I talked to some mentors. Rob Foreman is a co-founder of SalesLoft. He left the company before I did. So I talked to him for some career advice. Said, hey, I'm looking at switching jobs. This is kind of what I'm looking for. And I'm thinking of looking for jobs where they specifically do Elixir on the back end. And in a strong Arnold Schwarzenegger accent, he said, don't do it. But no kidding, it was just his normal voice. But he said, Devet, seriously, look for a company whose mission you can get behind, that you feel proud about what you're working on. Look for a company that's a culture fit for you, where you enjoy working with your team and your manager. And look for the right compensation so you can pay for the things that are more important than work regarding life, family, and everything else. And me disregarding that advice I felt something inside of me, which you'll probably get out throughout the talk, that I was like, no, I think I need to do this. But externally, it seems irresponsible and like I'm not following good advice, which just doesn't feel good to me. Okay, so more in support of Elixir, I want to talk about something called the blub paradox. It is made famous or coined in a blog post that's very verbose that you can go find, a long blog post. I'm going to try and make it much shorter. So let's imagine that for a given problem, not for anything, but for a given problem, and since we're at a web technologies conference, let's say for building a website, for building the average web application, there is a spectrum of power for programming languages. That assembly language is less powerful for solving that problem, and higher level languages like JavaScript, TypeScript, Python, Ruby, Java, C#, I don't want to offend anybody by leaving anybody out, but those are on the other end. They're most powerful, okay? Now, let's imagine Blub, made-up language, because I don't want to offend anybody yet, is right in the middle. It is in the middle of the power spectrum. It's more powerful than assembly, or maybe COBOL or Fortran, but much less powerful than the modern languages that I'm sure all of your backends are written in. Now imagine somebody, or imagine you, learned Blub in university, and you had a friend or family member that was a very successful Blub programmer, and so you got into a career doing Blub programming, you've been doing it for many years, you've been very successful. When you're looking at that spectrum and you look down, when you look at the less powerful languages, it is very obvious that you're looking down. You might shrug and go, how could I ever build anything in assembly because it doesn't even have XYZ feature that I use in Blub all the time. I use that in every single program I build. I use it every day. So since COBOL and Fortran and assembly doesn't have that feature, I don't know how I could get anything done in that. However, so it's very clear you're looking down. However, if you turned your head the other way and you looked up, you would see things that you've never worked with. You'd see things that your mentors or your coworkers have never seen or experienced the benefits of, and it would not be clear that you're looking up. You would just see, well, man, I've been able to, I don't know what this, maybe it's a garbage collection. I've been managing memory myself my whole programming career. Having a garbage collector seems like something I wouldn't trust anyways. It just seems useless, or it seems obscure. Like, why would anybody ever use a type system or whatever it is that Blub does not have if you've never tried it? So the challenge from the Pragmatic Programmer book is that you learn a new language every year, which, quite honestly, I haven't done. But beware of that. None of us want to be that person that is looking at a more capable technology for solving our problem, and we're like, nah, it seems like a solution without a problem. So with that, what is Elixir? It's a modern language with an ergonomic syntax. So let's keep going there. It compiles to Beam bytecode, just like Erlang. So Beam is the VM for Elixir and Erlang. And there's a few languages that compile to the Beam, but Erlang was the original one. And Elixir is now a modern syntax. So the Beam is to Erlang as the JVM is to Java. And maybe Kotlin is to the Beam as Elixir is to, Kotlin is to the JVM as Elixir is to the Beam. It's the more modern syntax for doing the same things as the older language did. Depending on your level of seniority, one of these 2 points on the board should mean more to you than the other. If you're a junior engineer or a mid-level engineer, the make or break time at work for you is getting the code working. If you're a junior engineer and you're good at getting the code working, well, obviously you need to read the business requirements, understand what they want, but that's any job anywhere, in or out of software. But getting the code working or knowing when to ask for help, if you've been stuck for an hour and you haven't made any progress, ask for help. If you can nail that as a junior engineer, you are exceeding the expectations and you will get promoted to mid-level. And at mid-level, the expectation is probably just that you do even more of that, do it even better. Maybe be the person that helps get some junior engineers unstuck. So at those levels of seniority, the syntax seems quite important. But something's going to happen as you're trying to demonstrate you're ready for the promotion to senior software engineer, or when you're a senior software engineer. The business will come to you and ask, hey, we're going to build this new feature. You go talk to product and find out what they want. And then you design for us, build some diagrams, and plan out how we're going to build this. And the rest of the team will write the code. And according to your plan. And then let's say you do that. Let's say you find out exactly what the business wants. You negotiate with them on scope, and you give them a range estimate of more or less how long it will take to deliver it. And you were correct in that because you successfully communicated to your team and they deliver it exactly as you planned. The scary thing is, we don't yet know if you succeeded or not. Because as a junior engineer, if the code works, you succeeded. Done. Gold star. As a senior engineer, if you made a technical design, part of the measurement of success is how does it work in production? How does it run? Does it scale? How is the uptime? How much are we spending on server resources? And so for you, if that's your situation, you should be much more concerned with the runtime characteristics. And that's what the Beam is going to give you. Or for example, the Go programming language didn't bring out any new syntax. It brought good runtime characteristics. It runs quickly using very little memory. And depending on your seniority, you care more about the one than the other. So we've been touching on architecture. Here is an architecture diagram. Simplest one we could probably make for a web application, browser, app server, database. Here's another one, browser, app server, and CDN, the CDN for some static assets. And then let's just say it's a Postgres database and an Elasticsearch cluster. So I'm going to say the first thing for which I might really be disliked. If you work on a web application and your architecture is more complicated than this, and you have less traffic than 25 million active users a month, and your app is less complex, it does less things than Cars.com, then the person who architected it might have failed. They might have failed at providing the business with the lowest cost architecture possible that would satisfy the functional and non-functional requirements. And in any architecture book, cost would be covered, and in almost any architecture book, it would kind of point out that a monolith is the cheapest architecture. So this really is the architecture for Cars.com. There is no Nginx, there is no Redis. The caching happens in the app server because the Beam can do caching. Sure, yeah, the ingestion pipeline that ingests all the millions of cars from the nationwide dealers does use SQS. But if you go to Cars.com right now, you're just interacting with this. However, there's a good chance that that architect, or if it was you, did not fail because very few runtimes would support a monolithic architecture at that scale. Usually, and there's a good chance that you didn't even have the option to choose Elixir. There's a good chance that the business already said, this is our backend technology, this is what you will choose. And given that constraint, you might have needed to build a much more complex, more expensive architecture. Okay, when is Elixir a good fit? For I/O bottlenecked requests over CPU bottlenecked requests. If you have CPU bottlenecked requests, if the requests are coming in, if the request is an image or large, high-resolution images that are going to come in, you're going to take them in memory into the runtime of your programming language and either resize them or run something on them, and then spit back a smaller image or a vector of it or something, then you're going to need a lot of CPU power. They're going to be CPU bound, and Elixir will not be the best choice. I'm going to guess Go or Rust to be really, really good at that. So yeah, CPU bottleneck. Now again, if it's CPU bottleneck request and you're comparing Elixir to a interpreted language, then yes, Elixir is going to be really good. But Elixir is compiled, so it's only fair to compare it to compiled languages. And among other compiled languages, Elixir is not good for transcoding a video or doing other things you would do with a compiled language. If you're doing that in Elixir, you're calling out to some other low-level library to do it outside of Elixir. But if it's I/O bottleneck requests, Elixir would be the preference. Also, if your P95 latency is more important to you than your P50. So your P50 latency is where half of your requests are slower than that, and half of your requests are faster than that. Let's say that is 150 milliseconds or whatever. If that is most important to you, then Elixir might not be for you. If you're getting a bunch of trades that are coming in to trade things on Wall Street or something, and as long as half of the time you can beat your competitors with a faster latency, that's when you make money, then yeah, I don't think Elixir is it. If you care more, if you have users trying to use the app and you need it to be usable for all of them, and your P95 latency where 5% of your requests are slower and 95% of your requests are faster. So these are the slower requests when the system might be getting a burst of traffic or something. If that's more important to you, Elixir optimizes more for that. And both these first two are because of two party tricks of the beam that kind of works together. The first party trick is that it can start millions of processes on the same machine. Even a modest laptop that any of you have brought here, you could start millions of processes, beam processes on your laptop. And because those processes have their own very lightweight, quick to create, quick to shut down, it would only make sense for any web server written in that runs on the beam that each web request that comes in gets its own process. And processes they don't share any memory with each other. They each have their own garbage collection. So as these requests come in, there won't be a moment where everything is garbage collecting at the same time and the requests that come in at that moment are being slowed down. The other party trick of the beam is the CPU scheduler. And I'm not saying it's better, it's just a trade-off. It is why Elixir is weaker at CPU tasks, is because of how the scheduler works. It will look at all those, let's say you've got 10,000 requests per second coming into your system. And 10,000 requests show up. All of them need to use the CPU for something. They will all go get in line. The scheduler will make basically a queue in front of each logical CPU core. So if you've got 16 CPU cores, there'll be 16 queues for all these processes to go get in. And if a process gets to the front of the line and starts using the CPU, then after 2,000 function calls, they have to go get back in the back of the line. So again, if you're trying to do some CPU-bound task, because you're now task switching, it's not going to be most efficient. However, if it's I/O bottlenecked and each process only needs a little bit of CPU time and then can wait, Elixir performs way better. And in an anomalous situation where you get a few requests coming in that all tries to use 100% of the CPU, they can't hog up the CPU. So the latency for all the other requests still seem fine. There's a great talk about this called The Soul of Erlang and Elixir on YouTube, or come ask me about it afterwards. It's talking more about the runtime characteristics just of the beam. Are you responsible to keep the system running? Another kind of obscure feature of the beam is that these processes can manage each other and restart each other when one dies. And you can configure what to do when that happens. So you could have a monolith where parts of the system might crash, and even if it's in a crash loop, the crash does not cascade to the rest of the system. Or you can configure it so that, hey, if this piece starts crash looping, make it bubble up to the top, and the whole thing should restart to hopefully come back with better data. So yeah, if you're responsible to keep the thing running, then Elixir is a good fit. It is very well known for its uptime. To my knowledge, systems running on the beam are the only systems that can be planned to have zero planned and unplanned downtime. There's another good talk on YouTube called Project Water Park, where they talk about how they do this. They have a healthcare system with zero planned downtime and zero unplanned downtime. And doing that without the beam is, to my knowledge, impossible. All right, so can you live without a static type system? This could be a deal breaker for many. Elixir does not have a static type system yet. It's being worked on. There's a third-party library that we use at Cars that does static type checking. No one really, likes it all that much in the Elixir community, but the Elixir team is working on a static type system. It's a system called set theoretic types, which there's research behind why it's a good idea, and it's going to be interesting to see what they come up with. But for now, if you have to have a static type system, deal breaker. Reduced engineering hours over the ability to hire 200 experienced engineers in a month. If your business had a good quarter, really good quarter, and the CFO said, hey, we can increase the engineering budget by the most we've ever increased it, and you're like, cool, we could hire 200 full-time engineers with this money. Let's go do it. If you want to hire people with Elixir experience, there might not be enough liquidity in the job market for you to go and do that without meaningfully driving up the paychecks of Elixir engineers. So that is a downside. If you're Facebook, Amazon, Netflix, or Google, you will need to have a serious plan about how you're going to hire people with no Elixir experience and ramp them up. I've seen that done very successfully in previous years when the job market was better for all of us, where I was working at SalesLoft. We want Elixir people, can't find them in the job market. We hire somebody with other experience and just ramp them up onto Elixir. And it works fine. But if you want to hire a whole team, all with Elixir experience, you're going to have a tough time. At Cars right now, our job requirements say that we look for Elixir experience. So the job market is good enough for that. Can you use something unconventional? Are you working in a large enterprise where they're saying, no, we do not want anything unconventional? Elixir has snuck into 2 enterprises that I know of, Pepsi and Estee Lauder. But in general, a large enterprise is going to say, we'll use our existing technology and we don't want something new. And yeah, what would it do to your reputation at work if you were to choose something really unconventional and then something went wrong? It is something to consider. Did you already choose an unconventional or old enterprise data store? I happen to know from conversations that, I think it was CouchDB, does not currently have a driver for Elixir. So CouchDB is unconventional, it's not very common. But if you've chosen that, you're like, we want to use CouchDB, and now you decide we want to use Elixir, you will be creating the CouchDB driver in Elixir, which is not beneficial for the business paying for all this. It's cool for the engineers that, hey, we're the first ones. For the business, they get no value out of that. So that could be a ding against. And also, old enterprise things, I haven't talked to people in the Elixir community that uses Oracle as a database. And I haven't talked to people in the Elixir community that uses SQL Server and are very happy with the integration. So maybe it's gotten much better since the last conversation I had, but it is a limited library support. For more common things, Kafka, SQS, all the AWS stuff, a lot of common API things, you're going to have support, no problem. The language is mature enough to get you there. Okay, finally, what is Liveview? It is a feature of Elixir's Phoenix framework. Phoenix is the main web framework in Elixir. So this slide, the credit goes to Pragmatic Studios. If you want to learn Elixir or Phoenix or Liveview, Pragmatic Studios makes the best videos I know of. They are also not a subscription. You pay an upfront fee, and you can do 1/3 of the videos or whatever, and then a year later continue or redo them. I've redone all of their courses, and yeah, they're great. So I grabbed the slides right off their website without permission, while knowing that I've personally talked to Mike and Nicole both. They're lovely people, and I knew I'm going to give them a roaring review. So I knew they wouldn't mind. So the best place to go learn Elixir and Liveview, Pragmatic Studios. So what happens is, with an Elixir request lifecycle, the browser here on the left box makes a request to the server. Phoenix router will see, okay, you want /lite? Well, that is a live route. I'll send you to the LiteLive module. The LiteLive module in the mount function will set the assigns. We're going to say, okay, the brightness is going to be 10. And then the render function is going to happen. That 10 is going to go into the spots where you've defined in your code where the dynamic bits of the page are. And then a full page of HTML is sent back to the client. And you're beating your competitors at SEO, because Google really likes when the page just server-side renders and is loaded on the server side. HTML, page is finished. The next thing that happens is that complete page of HTML, CSS, and JavaScript that you received happens to have a JavaScript client on it that knows to reach out to the same route that it was loaded from, and it makes a request again, but this time it's a WebSocket request to the same route. The same mount function runs, and it sets the assigns again to 10. The downside here is we've hit our database a second time unless we cached. And now something interesting happens. The render function happens, but it gives, and those two orange boxes on the right, it gives indexes to all of the dynamic bits on the page and sends the static bits and the dynamic bits over the WebSocket. And then the JavaScript client is like, hey, I know this is already rendered, but I'm going to be the one updating this page from now on, so I just like to re-render it myself from start. So the page does re-render, but the user can't see it. Unless the dynamic bits are random, you're going to have to do a little bit of work to make sure it's the same bit every time. We have to do that with ads on cars.com. We can't show you one ad for the dead renderer and another ad for the live render. So again, I'm not saying it's perfect, but server-side rendering is built in. And here comes the secret sauce. Now we have a WebSocket connection established, and it remains for as long as the user is on that page. And if they click the on button, we just send an on event. That's it. So we're sending very little up to the server. And what the server is sending back is everything you see in orange in the circle there. The server just sends back thing at element index 0 is a value 100, and thing at index 1 is a value 100, and it just sends back a tiny data structure just with the dynamic content. So after you've gotten to the connected render, the amount of data being sent back and forth between the client and server is as little as it could be. You can't make a framework or anything that sends less data than just indexes and values over to the client. And then the JavaScript client knows, okay, that the element at index 0 and index 1 is what I'll go and update. The other nice thing about this model is that because the WebSocket is connected and the server controls the state, which then gets sent to the client, If the server knows about new state, it can just update it and send it to the client without the client having to ask for it or do anything. So anything real time is just kind of a no-brainer. Okay, when is Liveview a good fit? Number one, if it needs a backend. If you're building a investment calculator or retirement investment calculator or something, or I thought of making all of these as a quiz that you can go to a website and just do a quiz and like points, you got points towards using Liveview in your situation and points against. That does not need a backend. If it doesn't need a backend, don't use Liveview, just do it in JavaScript or pick a JavaScript framework or something. It would make no sense. And that one to me is a deal breaker. Unless you're learning and doing a side project, then do whatever. But for actual business thing, if it can just run in the client's computer, just do that. If you do not need real-time functionality, it's hard to tell the future. None of us know if in the future our product manager could ask us for real-time functionality, or if our competitor could do something real-time. It happened to us at Cars last month, where I don't think we have anything real-time on the Cars website, really. We might have a few things here and there. But for my team, the product manager asked, hey, can we make this real-time? So that if the data updates on the back end, we just change it on the user's UI without them having to touch anything or do anything. And because we already used Liveview, it was very straightforward. There was no conversation with architecture. There was no, okay, there was a conversation about architecture, about what we're doing, but there was no change in architecture, no change with cloud on needing new services or new data stores or anything. That very simple architecture we have is what we kept using. Will you be building an API for the same functionality as web? This one is nuanced, but I feel like it's kind of important. If you're building a web application and whatever functionality is on the web, you will need to be building on the mobile app as well, then you will need to build an API for that functionality. So you cannot skip building an API. So the benefit that Liveview can give you, one of the benefits of Liveview is that you can skip building an API, but in that case, you can't. So you just don't get that benefit of Liveview. And at Cars.com, we're in that boat. We want our mobile app to do all the same things as the web. And so we build an API for the mobile app, but the web doesn't use it because Liveview doesn't use an API. So again, it doesn't mean you can't use Liveview. It's just a point against using Liveview. Do you have sensitive data in your database? Now, this one kind of goes with the previous one as well. If you have to build an API anyways, because it's a mobile app, and you have to validate, obviously, every single framework there is going to have some way to make sure that certain fields don't make it to the API response. But at what point do you validate, and who validates that? Can a lawyer just go to the page and see that, or do they need to open Chrome DevTools and find the right request? Or do they need to learn how to use Postman to inspect the response, to see and make sure that no private values came to the client? If you are not going to build an API, and you just build it with Liveview, then anybody that can load a web page can look at it and see all the values that a hacker would see if they inspect the page. And so if you get to skip building an API, you get to have easier verification of sensitive data for healthcare or GDPR or whatever reason. Less code over better developer tooling. Now, again, I told you I'll be honest with you today. Liveview developer tooling is not at the same level as Vue, Angular, or React. It just is not. The level of IntelliSense or other things you'll get in your editor is not there. Some compiling tools being written in JavaScript, being written for JavaScript, is being written in Go or being written in Rust to make super fast compile times, or React Storybook was the last thing of its kind I used in React. There are probably more modern things. where you can have this library of components that you can interact with and pass props in and see how they behave. Liveview will have things like that, but they are not as mature, and they probably will not be for many years, and maybe they will never be. So if developer tooling is more important to you than having less code, then Liveview is not for you. However, I'd like to make the point that usually you read the code more times than you write it. And the developer tooling usually helps in writing the code. Having less code is, in my opinion, a stronger benefit, but it is a downside to switching. If you're evaluating Liveview against some of the other front-end frameworks that this conference is about. Do you care about SEO for your app? Again, this is a point against or for Liveview. Well, I guess it's not against Liveview if you don't care about SEO. Again, I used to work at SalesLoft. We did not care about SEO for the app. We just needed to be fast for the users. If you turn JavaScript off and you load app.salesloft.com, I'm assuming you'll get a blank page, and that is perfectly fine. We cared about, I think, salesloft.com, because that was the website about the app that absolutely we cared about SEO. That's a separate story. At cars.com, cars.com is the app and the website. We absolutely care about SEO, and we want to beat our competitors. And when you turn off, you can go search for a car and then turn off JavaScript after you've found your car, because navigation's broken without JavaScript. But after you've found the search criteria you're looking for, you see a list of cars, you can turn off JavaScript, reload the page, and all the cars are still there. Things are not interactive. You can't click on things, and links are broken, all kinds of things. But if Google's crawler comes to the page and they try to index it, they're getting a quick response of HTML and CSS from the app, server rendered by default. So if you care about SEO, I think it's a point in favor of Liveview. Now, again, I'm not saying it automatically makes you amazing at SEO. You still, if you care about SEO, you're going to have to spend time on it specifically, realize where things are slow, realize where you can improve. But out of the box, it gives you a head start. And this last one, if I don't properly communicate the nuance of my last point here, I might never be invited back to speak at ElixirConf. So I'm going to carefully thread the needle here. If you have, will you have less than 25 million active users per month? So cars.com is the Liveview app with the most traffic. And while that might be fun for engineers, or might be fun to brag about over a round of beers, it gives the business absolutely zero benefit. And sometimes maybe a little bit of cost. Because we could run into some kind of a scaling bottleneck or something that's bothering us with scaling. And then we need to resolve that. We're not going to find some blog post on the internet from how somebody else resolved it, because we're the first ones to run into it. And the Phoenix core team is amazing. If ever we need to do something custom to make it perform better, we can reach out to them, and they will be very open to just make it a configuration that you can just put on Phoenix, and that could just be something we configure in the future. So they're very easy to talk to, open people. Phoenix core team's amazing. And again, I want to make sure I say this, just so I get invited back to ElixirConf, that Liveview is just using Phoenix WebSockets. Phoenix channels is the feature. You can absolutely do it without Liveview. If you want to build a real-time phone app of some kind, or a real-time app with JavaScript or React, Vue, Angular on the front end, and you want to connect to WebSockets, I would strongly recommend Phoenix and Elixir as your backend. It is excellent at that. Phoenix has been shown and benchmarked and everything. It can handle 2 million WebSocket connections sustained with one server. And so if you do some math, then with about 3,000 servers, you could connect every single internet user in the world to a Phoenix app, which is the best you're going to get. And so theoretically, Liveview could get there, but it just hasn't. So there is a second mover advantage to being the one that uses the technology at its utmost scale. WhatsApp is an example of a company that runs on the beam that also does it at immense scale. They also have 2 million phones connected to each server, and they actually, as of the last time I looked, they handle 1.6 million messages per second. So again, Elixir doing very well at those outliers of lots and lots of scale. So, man, this computer going to sleep. Now what? I just want to challenge you that if you heard if the scenarios I described for Elixir or Liveview doesn't match your scenario at all, then you can safely go about your day and know that, okay, fine, I heard about this thing that I'm not going to use, and I'm moving on with my life. And you probably got the most value out of this talk, because then you know one more thing you don't need to know about. But if you listen through all of this and you realize, hey, wait a minute, my scenario in which I'm building this application or in which I need to design this system sounds a lot like the scenario in which Elixir or Liveview would be a great fit, I want to challenge you not to be that blub programmer that looks at the more powerful tool for the problem they're trying to solve and go, you know, it seems obscure. Who would ever use that? Seems like a solution without a problem. So with that, thank you very much. All right, any questions?
So what's the biggest problem that you ran into using Elixir other than the stuff that you covered? Like what's the thing that stands out to like, why did I ever pick this tech stack?
I can think of 2 outages at Salesloft that was caused by Elixir. So Elixir, because it can create just so many processes so cheaply, we had a Kafka client that was reading from a Kafka topic that had 64 partitions. And so why would the library author not just make a separate Elixir process for each partition? So you've got 64 separate processes reading from Kafka. And so the nice thing about Elixir is oftentimes you're just writing single-threaded code. Because your code is running in a separate process from everybody else's, you never really think about concurrency all that much. So we just wrote our code that, yeah, we're going to get the stuff from Kafka and send it to Elasticsearch. Why not? Elasticsearch did not want to get 64 different sets of data from 64 processes over and over as they're all reading from Kafka. Elasticsearch likes things in much bigger batches. So yeah, Elasticsearch just stopped responding when we turned that on. So that's one scenario where it's like, okay, yes, you've got this language that can do things really, really fast, but it does mean you can scale until you take out your data source. And it might do that by default, where if it was something else, by default it might not have been fast enough, but that's a better problem to have sometimes. Another outage was we built a router at Salesloft that would take in all the traffic and look at certain aspects of the request and route the request to an Elixir server in the United States or in Europe. We wanted all the European users to have their data remain in Europe. So that thing started up, and we noticed, oh, it's routing requests to a server that needs like 2 gigs of RAM, but it by itself only runs on like 500 megs of RAM. And so we kind of flexed, and we're like, cool, yeah, this thing only needs 800 megs of memory, or 600 or something, because look at how amazing Elixir is. And then, because it doesn't queue, because it can take in those 10,000 requests all at the same time, like I was talking earlier, it doesn't throw things into a queue. It just starts handling all of them and holds on to those requests until it can finish them. We had an outage in one of our regions, and all the requests for that region just piled up in this router, and it ran out of memory and crashed, and took out all the regions. So all it needed was more memory. It needed us to be more humble. But yeah, in both cases, Elixir being able to just be like, yeah, I can do more, I can do more, I can do more, either made us run out of memory or run out of what the data store can handle. And again, I'd rather have those problems. I'd rather have an outage once and then fix it than having, oh, it's too slow, and we need to have a complete architecture conversation about how do we ever make this faster because our runtime cannot.
To be fair, circuit breakers.
Yes. Absolutely. Anyways, I'm going to be here. I'm going to be hanging out. If anybody wants to come talk to me about Elixir or Liveview, I'm available, or about anything else. But thank you all so much for coming. I appreciate it.